Hello and welcome everyone to this webinar where we will be presenting our new self-unloading solution called the MacGregor GravityVibe. My name is Jonas Persson. I'm a sales director here at the MacGregor Cargo Access Solutions. And with me in our office here in Gothenburg, I have Mikael Hägglund, sales manager, and Mikael Jakobsson, sales project manager. And the two of you will cover most of the presentation part, since you have much more experience from this equipment than what I do. In today's webinar, Mikael will present the solution, and towards the end we will have time for some questions and answers. You can post questions in the right-hand side of your screen. There is an icon for questions. So please post questions throughout the webinar. First out will be Mikael Jakobsson. You will cover the technical part of the solution, and then Mikael Hägglund, you will focus more on the added value that we see with this solution. The webinar will be recorded and will be made available to you in the coming few days afterwards. So again, a warm welcome, and with that I hand over to you, Mikael.
Yeah, thank you. Let's start with look at a traditional type of gravity self-unloader for a comparison's sake. What you see on the screen is a fairly small self-unloader. It's 9K, 9,000 deadweight tons. You see two rows of hoppers. You see two rows with the gates. These gates drop the cargo onto conveyors that's on the tank top. In this case, to take it to the forward part of the ship, transloads the material onto the cross conveyors that takes it to the center line, and then we take the elevation with the C-loop up to deck level. And if we look at specifically a gate in close-up, it will look something like this. So in the traditional setup, we would need a siding inclination of the hoppers of about 35 to 60 degrees, depending on which cargo and in what condition we're running it. So we need these hopper angles quite steep in order to make sure that the cargo flow out of the hopper fully by gravity. And if we look into the new GravityVibe concept, we start with looking at the traditional cross-section of the bottom part of the hopper. This idea came about as a study on running materials with high internal friction, especially wood chips. And these cargoes has a tendency when you unload them to either bridge the opening, this is all you get out of the hold, or you can have rat holing or vertical walls, which is also where you sort of will end up with your unloading. This is as far as you get. And studying this, we realized that if we introduce vibrations into the cargo, we can break these frictions and get the material flowing. And not only do we get the material flowing, we also realized that we no longer need the higher inclinations of the hopper walls. So in this setup, we can go as low as 15 to 20 degrees. So when we unload in this scenario, we will open the gate and let the cargo flow out freely by itself, not using vibrators. This, of course, will leave us with a residual area that is not unloaded yet. So we add the vibration in this stage and do a complete emptying of the hold. And if we look at an animation of this, sorry. So here you see the last part of the unloading where we're using the vibrating panels, or the GravityVibe system as we call it. You can see that the panels are working in sections. And you also can see that you have a feed rate from the vibrating panels into the gate that exceeds what the conveyor can take out of it. Have a look at it once more.
We got this bonus time.
Okay. So, as a result of being able to use sidewall inclinations that are much lower, we actually can take away one row of hoppers, one row of gates, one whole conveyor, and both of the cross conveyors, and still essentially run the same volume with just one conveyor, one gate, one row of hoppers. And if you look at what the GravityVibe self-unloader will look like, we see the picture that we started off with on the left, and what will look like in the GravityVibe setup on the right. And as you can see, we only have one row of hoppers and one row of gates. And if we continue as we did before, we look at one gate specifically, we can see here that we are at much lower inclinations of the side angles. And the areas shown in orange is the areas where we have applied these vibration panels. So if you look at one of the panels specifically and see how it works, it starts with a supporting structure. This support structure is isolated with vibration isolators under each foot and also against the wall of the side wall of the cargo hold. And this means that we are not transmitting any vibrations or any sound into the hull structure. On top of this structure, we also have a vibrating isolation element. And on top of that, we have the vibration panel itself. And if we look at the back side of it for clarity's sake, we can see at the bottom we have the support structure. We have the isolating elements, and on top you can see the vibrating panel with its hydraulic vibrators in yellow. And also one consequence of this, if you look at the traditional setup compared to the new setup, is that of course we don't need the cross conveyors anymore. And we also don't need to raise up the back end of the whole conveyor to do the reloading into the cross conveyors. And this means we can do a much more direct loading of the sea conveyor, or in some cases on small ships, we can actually use the outer loop as the conveyor belt to the whole conveyor. And with that, I'll turn over to you, Michael.
Thank you, thank you. So my part, I will talk a little bit about the added values the system can give, and talking about the cargo flow, the capacity, the flexibility, and also a little bit about the installations and our experience regarding this one. So as Mikael was mentioning a little bit, this system actually, the thought was coming from a problem that we have, and we saw that this could be a solution for that one. So we have, we come from curiosity, we based this solution. And starting up with looking at the improved cargo flow, then we can actually start looking, as we see in the old traditional system, with 2 holes, and this is quite common even for rather small vessels, that we need that in order to make the material flow down to the gates. And that means that we also have, as you can see in the circles here, we have these 3 transition points where the material both needs to be transferred but also change direction and speed. This can cause problems depending on which material you have. So, of course, if you're looking at with a new system, we have, as Mikael have explained, first of all, this modular system, which will give the material easy way down to the whole conveyor, and then we have this less risk for bridging and that rat hole will occur. The next part is, of course, the simplicity of having one conveyor and one direction for the material to go, taking away all the problems that can appear in this transitions areas. So what we have here is that we actually take away 3 transfer points. We have it reduced to 1, or in some cases, as Mikael mentioned, we are actually have no transition points. We can actually use the outer loop of the C loop to extend that one. And one other part, which is also the improvement of the cargo flow, is that we can do this loading and unloading independent of the weather. If we are not sensitive for rain and such, this could be done very efficiently, and you save time in port and you save money as well. So what we can say that you have a very high output of the discharge, 46,000 tons per hour. It's quite normal for this system, and we improve the reliability. We make it a simple system, and we also reduce the risk for downtime due to the fact that things can happen. Next part is, of course, the increased flexibility. And what do I mean by that? We can see that you have the cargo hold 15 to 20 degrees. And since this system now can actually operate the material that are having free flow more than 20 or 15 degrees, maybe even up to 60 degrees in this system, you give them a possibility to operate with a wider range of materials. And of course, you will also have an increased potential for the vessel. You have possibilities to take more different kind of charters, different kind of materials, etc. And in some cases, you also will have quite big earnings of the volume. So we also see that now when we are comprising this system more efficiently, there is also actually an increased market even for smaller vessels to use this kind of system, because the efficiency will be higher than we have seen in the traditional systems. I will come to that, and I'll give some examples later on as well in the presentation. We can take cargo capacity as one part, and of course this is an area where you actually have a lot of different factors that are needed to be checked as well. You have, depends on the size of the vessel, it depends on the shape of the vessel, the intended cargoes that you are intend to have. If you have more than one type of cargo, so you need to be sure that every material can be handled. Of course, also the material flow properties are very important. Angle of repose, density of the material, also what kind of consistent material it is. It's the grain, particle size, etc. So what general impact does the MacGregor gravity system have then on the capacity? We can actually start to looking at on one example that we are having on the picture. We are taking as an example quite big vessel, 30k deadweight ton, self-unloading gravity with 2 holes and 45 degrees angle. It will give you around 36,984 cubic meters of volume. If you, for instance, then take the example of having the gravity solution, now with 1 single hole, and we have also 15 degrees in the bottom of the hole, we actually increase the volume with 11% compared to the first one, giving slightly over 40,000 cubic meters. Here in this scenario, you have also taken away 1 whole conveyor, 1 cross conveyor, so you have reduced the installation of the vessel. And there also a third alternative which you can actually do, and that is having actually this more or less the same setup than before, that you have 2 whole conveyors and the cross conveyor, and you optimize the volume, because in this scenario you actually the gravity system could give you up to 15% more volume. We are reaching 42,456 cubic meters for this solution. And of course, looking at the latest scenario, it's important to have all the factors, because when you're looking at this kind of system, we offshore wants to point out that we are looking both of the initial investment, the capex, but also the operating expenses that you have throughout the lifetime. So cargo volume is of course one important parameter of this, but you have others as well. And that comes also to give you another example. And for this one, we are going a little bit more small in size. We are looking at a vessel which are around 5 to 6K. And this is a case which we actually have been discussing with owners, etc. And for this one, they were transporting 2 types of materials. One material was sticky wet sand, and which had then a requirement of 60 degrees for angular repose, and also other aggregates which then required around 45% of degrees. And looking at that, we actually come to the fact that calculating conservative with 20 degrees in all 6 holes, we would actually give a volume increase of 37% in this vessel. So you can see the exact figures on the left side here, the existing and the new setup. And of course, when you're looking at that, we also need to take, all the other aspects in the calculation. We are looking at the logistics. We are looking at the transport, both the distance, but also the tonnage. We are looking at how much fuel per day does it cost, how many million tons were expected to be transloaded, time for the loading, time for the unloading, etc. So putting all of this into the calculation, we actually came to the fact that we went from 290 transports per year. We could actually go down to 211. So more or less we saved 80 transports per year. And that was in estimated value up to 1.2 $2 million per year in savings. And looking at 20 years, then you can also take that, will create quite big numbers in savings on total lifetime of the vessel. So looking at it from this angle, then you can, of course, ask yourself, what would this kind of system be worth when we're talking about the MacGregor GravityVibe? So these are two examples. As you understand, there are extremely many examples we can take, but we only have 45 minutes to discuss. So we can go further on and talk about a little bit about the reduced equipment installation. And for this one, once again, the old system, 2 holes. We had a number of gates. We have the cross conveyor, etc. And if we're now looking at what we save here with the MacGregor GravityVibe, we can see, first of all, number of gates will be considerably reduced. We are talking about less than half. The next part is, of course, that we see that you are only producing 1 hole conveyor instead of 2 normally. And we have taken away the cross conveyor from the system. We, for this system, of course, we have also added some system with vibrators, so that's an increased cost. But we also see that you have made a modularized system, easier to assemble, and maybe also you have savings in time for assembling the vessel by having this kind of system. And then, of course, looking at the OPEX, the operating expenses during the lifetime, we see that for maintenance, of course, there are less components to service. We see also that it will be also reduced energy consumption, a small part for that, but it will not be so much. This, of course, is something that we actually are calculating right now. But we're taking away 2 systems, but it will not be a major factor in this one. And the last one, based on experience and validation, why do we believe that we have this system now and making this presentation? Once we started this one, I think it was 2.5 years ago. Yeah, this R&D project, and we had, as we said, we had a problem that we were standing in front of, and we went together, and the designers came up with this intelligent idea, and we then took this forward, and we have so forth. We have, first of all, MacGregor has been doing transloading, self-unloading equipments, both in cement and also for gravity solutions for many years. So we have that base for experience. And then, of course, we took also help. We made a cooperation with one of the, I think, most considered experts within this material properties, that is Tunra, which is the University of Newcastle in Australia, where we have been doing practical tests. We have doing with different materials. We have also made theoretical analysis. You saw one of those in the presentation that Mikael made. So we have been given most valuable output from these kinds of activities with Tunra. And then, of course, we have also had vibrations and sound levels on our agenda, because that is, of course, something that we see that we need to be taken care of. So we have also there been using third parties for this validation or analysis. And so far, we see that, you know, the analysis that we have done is actually far below that what the class requirements would require. And this depends, of course, that we are doing the system which is isolated more or less from the hull structure as well. And then, of course, one final point here is that we also, Cargotec and MacGregor has decided to build this full-scale test rig, which is under production right now. And we are doing this in order to verify that what we are saying is right, and that we have a solution for this one, which can take the materials that we want, and also for risk mitigation, both for MacGregor but also for the customer, future customers, so that there is a possibility for them as well to test the materials here in the future. So this is also something that we might come back to later on when the system is finalized. The last picture I have here is, of course, also relating to the patent which we have been sent in, and that has been sent in for quite a long time ago. We have now covered the vessel and the zero gravity system inside the vessel in this presentation, but the patent covers as well the hoppers as well. And here it's quite interesting part, because looking at the hoppers, we see that you can save, first of all, considerable amount of weight doing this new system, and you do that while you still have a bigger hit area for grabs and such equipment to reach the hopper. So that means that you also have a benefit of that from cost point of view, but also from performance point of view. And the final part is that looking also on a vessel, you see that this kind of new hopper will also have a reduced height, and we say more than 4 meters based on an existing solution that we have, and that will give you increased turn capacity. You have to imagine on the picture here that you have MacGregor electric transloading crane as well. But for that one, you actually increase the performance of the system. You save time, and that gives you high performance. The final part is actually also that the patent also is covering onshore storage. Oops, I was too fast there. So onshore storage, where you can have in ports the material, and you have this system GravityVibe for easy logistics. So that is also, the sky is the limit here, how you will do the system. So this was a little bit of the added values I would like to bring and to show what this GravityVibe could do. And of course, we are here now, sitting here. You have some pictures on us and also some references here on emails. So we are absolutely available later on to take contact if you have any projects that needs attention.
Thank you, Mikael, and thank you, Mikael, for that. Now let's try to give answers to some of the questions we have received. We have received quite a lot of questions. If we start off with technical questions, there are more technical questions, I can say. But if we start with one regarding internal friction angles, what is the internal friction angle of the materials considered, or what materials are considered? What materials have we considered in our study?
For the practical test we have done, we have actually been doing 3 materials. We have been doing coal, we have been doing wet sticky sand, and also wood chip. Then we have in the total portfolio, I think it was more than 19 different kind of materials that we have, in selecting also.
But then, as presented with the new test rig, then we will have the possibility to test whatever materials. I mean, to verify different materials. Then it's a question regarding the adding vibrations to our hoppers. What is new with that solution? I mean, vibrations has been used previously, so what is the new thing with this?
We are bringing sort of more vibration directly into the material. The traditional type is where you sort of bolt one vibrator to sort of the lower part of the hopper by the gate, and used to break bridging and things like that. Here we are vibrating the whole hopper bottom actually.
Thank you. Then this is a quite detailed question, but still interesting. I think it's regarding the resilient mounts. They have a certain capacity. As suggested here, they can maybe cope with 100 or 125 tons, something like that. Do they remain effective in this solution where we have a fully loaded ship?
Yeah, but you would have to look at it from two scenarios. I mean, you have the full loaded capacity when you have the full cargo load on them. But then when we start unloading as a standard gravity setup, we just use the gravity to empty as much as it can. And at that stage, we don't have the full load on the vibrators anymore. We only have the residual amount that we need to sort of do the vibration system of.
Right. Yeah, so we are not actually using the vibrators at all when they are loaded. No. Okay. Regarding weight, do we have any comparative figures with regarding lightship weight with a normal loading system and this one?
No, it's a good question and also a tough question. I mean, the support structure that we have for the vibrating panels are doing exactly the same job as the support structure in a regular gravity setup, the high angles. Of course, we are sort of having now with the lower angles, we have a smaller cross section and the legs are shorter. Of course, there we sort of gain some weight, but it also depends on how well you're able to design your support structure, how good you're using the steel. So it's a good question, but we don't have a definite answer. We think it will be likely.
And I mean, in the case where if there is a case where you're able to remove one of the longitudinal conveyors with all that associated equipment.
Yeah, if you look at the total equipment weight, we are taking away a lot, especially on the gate side. But just for sort of the support structure itself, it's about the same.
Yeah. Right. Regarding, I received the question if there is any requirements on putting a lining onto the cargo, so cargo hold.
Yeah, I mean that's the normal setup on quite many gravity type self-unloaders, that you have this plastic lining on the hopper walls to decrease friction. But we don't see that there is a need for that anymore.
So it's no lining whatsoever. Yeah. Do we see any materials that will not function with the system, such as stickier aggregates?
I mean, we still need a free-flowing material. If the material is sticky, it will still stick to the walls, even if we vibrate them. So.
Yeah, but as long as they are free-flowing, as you say, then we should be able to cope with this solution. What else? Yes, we have a question here regarding the vibrators as such. How are they powered, and have we considered various alternative ways of powering them?
Yeah, we are using hydraulics, and mainly because if you look at how many we have and what we want to do with them, we have concluded that the hydraulic drive is what we like.
Yeah. Another question related to the vibrating panels as such is that if there has been any concern on leakages, either by water or dust or small particles outside the hoppers to get stuck. Let me see, between hopper and vibrating panel.
Yeah, it's a very good question, and we have considered it. And there is a dual rubber sealing system that's supposed to prevent dust from entering below the panels.
Thank you. Let me see here now. It's some of the questions are quite long. Let me see. It's a question here regarding, yeah, cargoes causing damages to the hoppers. So the question is, have impact plates been considered? Some cargoes can cause damage to the hoppers when loaded. Would an impact plate be made separate or integrated from the vibrating hopper?
Yeah, and it's also a good question, and it also depends on what cargoes you're running and from which size into which hold height you're dropping it and so on. I mean, you won't damage anything with wood chips, but if you're running aggregates, you can sort of get big rocks. So the standard feature of having a sacrificial plate where you sort of start the loading is still applicable here. But in most scenarios, we can take any sort of load you can load into a standard gravity self-unloading to do this as well.
Yeah. Then a simple question that even I can give answer to is when will the test rig be ready? And the plan is that it will be up and running by May this year. So by then we will start, testing materials and so on, and then we are also opening up to do tests together with customers. If there is an interest for that. What more? Yeah, we have one here regarding wear of vibrating plates. Please advise if increased wear of vibrating plates are expected.
We don't see that. One thing is, of course, that you're only running the vibrators plates at the end of the unloading. And also is that it's actually so that when we are running the vibrators, we are decreasing the friction. So if anything, the wear will be less than if you have sort of this, just gravity flow over it.
And what about the vibrators themselves?
I mean, the vibrators are quite simple machine. It's a gear hydraulic motor connected to an extender through two load supporting bearings. It's a quite simple machine itself.
Yeah, and I mean, we have experience from using these vibrators ourselves for many years, so we're quite familiar with them. What more? I think we covered a big part of the questions actually. Let me see. Yeah, one thing here regarding the vibration and frequency and amplitude. Is there a possibility? Are they variable?
Yes. Yes.
And how is that? Is that manual control?
No, we do it through the PLC control, but we do vary the oil flow to the vibrator, so we are actually sort of controlling their speed.
And then, I mean, do we apply different vibrations or frequencies or amplitudes for different materials, or what is decisive?
Yeah, but essentially we are controlling where we have material on the panels or not. So when the panels are empty, we're actually not vibrating.
Okay.
Yeah.
Then let me see here. I have one question regarding, it's a question regarding, I guess, the presentation. How does elimination of 1 or 2 belts reduce the number of gates by greater than 50%? I don't recall exactly what you said on that topic, but
Yes, it's probably related to that. At least you can say that we are doing the half of the gates. But then, of course, we see also in some design that they've done that we have actually increased the size of the gates.
Okay, yeah.
So then we get less gates as well.
Yeah. So fewer mounts and only one row. If that explains the question.
Simply.
Yeah. With that, I think it's time to round off a little bit. We will provide answers for all the questions on email afterwards. We will also, as I believe I said in the start, we will make the webinar available, a recorded version made available, and send it to you. And as mentioned by you, Mikael, I mean, we are, of course, more than happy to continue the discussion with you, either regarding specific projects or just in general. And yeah, our contact details, we showed you them before, and we will include them also in what we send to you.
We can just add that also that we most likely might be coming up a new customer event when we have the test rig finalized, maybe.
Yeah, could be. Stay tuned for that.
Yeah.
No, but that will be very exciting to see the results. No, but I would like to thank you so much for spending time with us. I hope you found the webinar interesting, and we look forward to talking to you again. Thank you and goodbye.
Thank you.
Thank you.